This topic is about the sine rule, cosine rule, and the area of the triangle rule. You need to be able to know when to apply which rule to accurately find out missing lengths and angles. We also need to be able to solve complex problems involving these rules. The first thing you need to know is how to draw the triangle and label the triangle correctly. So if I draw any old triangle, so in these cases it doesn't need to be a right angle triangle, then I need to label the lengths as A, B and C, so the lowercase. Now opposite the lowercase a, we need to label the angle as uppercase A. So opposite the lowercase b, I need to label this angle uppercase B, and opposite the lowercase c length, I need to have the angle that's labeled as uppercase C. So it's very important that you label the triangle correctly. Now the sine rule, there's two different versions. So the first version is sine A over little a is equal to sine B over little b, which is equal to sine C over the little c. Now we use this version of the formula when we're trying to find a missing angle, because it makes rearranging easier. So the angle needs to be at the top. So sine A, sine B and sine C need to be at the top. Now the other version is if it's inverted. So it's the same thing as A over sine A is equal to B over sine B, which is equal to C over sine C. Again, we use this one when we're trying to find a missing length. Okay, you only need to memorize one version. You don't need to know both versions. And it's quite easy to memorize these anyway. Okay, the next rule is the cosine rule. Okay, the cosine rule, one version is a squared is equal to b squared plus c squared minus 2bc cosine A. Now because a squared, the lowercase a, is the subject of that formula, this one is more useful when you have a missing length, because the lowercase a represents a length. Now if you have a missing angle instead, it's easier to use this version, although you can always rearrange to get this version, so you don't need to memorize it. Cos A is equal to b squared plus c squared minus a squared over 2bc. So this is when you have a missing angle. And the last one is the area of a triangle rule. Which is area is equal to half times A times B times sine C. So the important thing is you have two lengths and the angle in between, because you've got AB sine C. So two lengths and the angle in between. Okay, so these three formulae are applied to any triangle. So it's not like SOHCAHTOA when it needs to be a right angle triangle. Sine, cosine, and the area of a triangle rule is applied to all triangles. Now, how do we decide which formula to use, whether we use the sine or the cosine rule? Because the area of a triangle rule is quite easy. You know, when it's the area, you apply that formula. So how do we know when to use sine rule or the cosine rule? So let's look at a few examples. So if you look at the question 1, so is it a sine rule or cosine rule? You look at, do you have a corresponding opposite length and angle? So if you look at it, you do know this opposite length and angle. So when you know an angle and length that are opposite each other, you know you can apply the sine rule to that one. In question 2, if you look at that question, you don't have a angle and length opposite each other, so you know you'll have to use the cosine rule in this case. If you look at question 3, again, you don't have an angle and length opposite each other, so that means a known angle and length opposite each other, so this means you have to use a cosine rule here. If you look at question 4, 12.6 and 31 are opposite length and angle, so we do know a value of a length and angle that are opposite each other. So that means I can apply the sine rule here. Question 5. You can see 30 degrees and 6 meters. So there are known opposite length and angle. So this means I can apply the sine rule. So now that I've gone through the concept, I want to go through a few examples. So let's start with example 1. Okay, in triangle PQR, side PQ has length 9 centimeter and side PR has length 10 centimeters. So if I were to roughly draw this out, we've got P to Q is equal to 9 centimeters and P to R is equal to 10 centimeters. Given that the area of PQR is 30 centimeters squared, so the area is 30 centimeters squared, find the length of QR. So we're trying to find this for A. Okay, so before we can find the length of QR, I think it's important that we find this angle. Okay, so because we know the area, I need to use the area of the triangle formula. So you're using area is equal to half AB sine C. I know that 30, which is the area, must be equal to half times 9 times 10 times sine of the angle at P. So QPR, angle QPR. Oops. Angle QPR. Okay, if I obviously simplify that, I get 90 is equal to half times 9 times 10, give me 45. So 45 sine, let's call this C, sine C, okay? So sine of C must be equal to 30 over 45, which simplifies to 2/3. Okay, because sine of C is equal to 2/3, C must be equal to inverse sine of 2/3, which means it must be equal to 41.8103149, blah, 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 which rounds to 41.8 degrees. So I know that the angle at P is 41.8 degrees. So now if I want to redraw this triangle, I've got 9 here, I've got 10 here, and I've got this angle at C, which is 41.8 degrees. So now I need to find out this. Let's call this A. Then if I'm using cosine rule, because I don't have an opposite length and angle, so using A squared is equal to B squared plus C squared minus 2BC cosine A. Then I know the length Q of R, because A is QR squared, A squared is QR squared, must be equal to 9 squared plus 10 squared minus 2 times 9 times 10 times cosine of 41.8 degrees. When I put this in my calculator, I use the non-rounded version, just so I get a more accurate answer. So when I do this, I get QR squared is equal to 46.8359, blah, blah, blah. So if I want to find out QR, I'm going to square root 46.8359, blah, 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 which means Q to R is equal to 6.84367, which means Q to R is equal to 6.84 centimeters. Okay, now part B. You find angle PQR. So PQR is this angle here, so B there. Now because we know what A is now, so we can use sine rule now. and we're trying to find a missing angle, so put the angle on top, use the angle on top version. So using sine A over A is equal to sine B over B. I get sine of the angle PQR over 10 is equal to sine of 41.8 over the answer that I just got, which is 6.84. Again, when I put this to my calculator, I'm using the non-rounded version. This means I get sine of angle PQR is equal to 0.97413. So angle PQR will be equal to inverse sine of 0.97413, which is a value of 76.9402. If I round this up, I get 76.9 degrees. Next example. In the triangle ABC, AB is equal to 13 centimeters, BC is equal to 10 centimeters, and angle BAC is equal to 30 degrees. Find two possible sizes of angle ABC, giving you answers to 2 decimal places. Okay, so if I draw this triangle out, okay, there must be 2 different versions of this triangle. We're getting 2 different answers. So we've got A, B, C. We've got A to B is 13 centimeters, so 13 here. B to C is 10. And angle BAC is equal to 30 degrees. Now the important thing is that we realize that's one version of the solution. That's how it could possibly look like. But if I were to draw another triangle like this, where this is C now, and that is also 10, then I'd get a different triangle. So if I redraw this one, then I can get a different triangle that satisfies the same conditions, which will look like this. So I've got A, B, and C, where A to B is still 13, B to C is 10, and A angle at A is 30 degrees. So there's 2 different triangles you can get. It says find the 2 possible value sizes of angle ABC. So you're trying to find this one, ABC, that one, and this one. Now in order to find the angle at B, because I don't know the opposite length to B, I need to actually find out angle ACB. So let's find out this, which is X, and this, which is X, first, before we can find our answer, which is Y. Okay, because we know opposite X, we've got 13. So first of all, I need to use the sine rule. So using sine A over A is equal to sine B over B. I get sine of angle ACB over 13 is equal to sine of 30 over 10. Now sine of ACB, the angle ACB is just X, so let's just call it X. So X must be equal to sine 30 over 10 times 13, which means X must be equal to 40, inverse. X must be equal to 40.5416, which means X must be equal to 40.54 to 2 decimal places, so degrees to 2 decimal places. So that was one of my solutions. So that would be my first solution, which is here, X is equal to 40.54. Now that is acute. Now my second answer for X must be an obtuse angle. Now from your GCSE knowledge, if you remember your sine graph starts at 0, gets back to 0 at 180, and then goes below the x-axis all the way for up to 360. Okay, so you know, let me just write the 360 properly. So 40.54, which is the solution, is somewhere here. 40.54. So to find the other solution, it must lie there. So that must be, the second solution must be, because this is 40.54, that part must also be 40.54. So the second solution must be 180 take away 40.54. 180 take away 40.54 is 139.4583, which means x must be equal to 139.46 degrees. So those are my values for x. If I want to find my values for y, because areas of angles in a triangle add up to 180, one of my solutions must be y is equal to 180 take away 30 take away 40.54, which gives me a value of 109.46. And my other value of y must be equal to 180 take away 30 take away 139.46, which gives me a value of 10.54. So my two possible values of angle ABC is equal to 109.46 or equal to 10.54. So those are my two solutions. So in these questions, when you get two possible values of an angle, once you found one of the answer, which is the acute answer, always do 180 take away the answer to get your second solution. So 180 take away the first solution to get your second solution. Next example. In a triangle ABC, AB is equal to x plus 3, ABC is equal to x plus 2, and AC is equal to x, and angle BAC is equal to 60 degrees. Find the value of x. So if I were to draw this out, again, draw your triangle. A, B, and C. A to B is equal to x plus 3. B to C is equal to x plus 2. A to C is x. The angle BAC, so BA to C, is equal to 60 degrees. Okay, find the value of x. Again, we do not have any known opposite angle and length. That means I do need to use the cosine rule. So using a squared is equal to b squared plus c squared minus 2bc cosine A. So in this case, because I know this one, this 60 degrees, this must be my A, this must be my little a, this must be my B, and that must be my C. So I do get x plus 2 squared is equal to x plus 3 squared plus x squared minus 2 times x plus 3 times x times cosine 60. Okay, if I expand this, I get x squared plus 2 lots of 2x plus 2 squared. If I expand x plus 3 squared, I get x squared plus 2 lots of 3x, which is 6x, plus 3 squared, which is 9, plus the x squared, minus 2 lots of x plus 3 times x times cosine 60, which is a half if you put into your calculator. Okay, if I simplify this, I get x squared plus 4x plus 4 on the left-hand side, x squared plus 6x plus 9 plus x squared minus 2 times x times a half gives me minus x squared, and minus 2 times 3 times x times a half gives me minus 3x. Okay, so if I simplify the right-hand side, I get x squared plus 4x plus 4 on the left-hand side still. x squared plus x squared, take away x squared gives me x squared. 6x take away 3x gives me positive 3x. 9 and plus 9. Okay, I've got an x squared on both sides, so I can cross it out and simplify it. If I take the 3x to the left-hand side, I'm left with x. 4x take away 3x, which is x. And 9 take away 4 is 5. So x is equal to 5 centimeters. Given the area of a triangle ABC is 12 centimeters squared, find the exact value of x and find the length of BC. Okay, so for part A, so using area of a triangle is equal to half AB sine C. I get 12 must be equal to half times 2x times 3x times sine of 30. So 12 is equal to half times 2x times 3x times sine 30, which is a half. Okay, if I simplify the right hand side, 2x times 3x gives me 6x, 6x times half gives me 3x, 3x times half gives me 3x over 2. Which means 24 must be equal to 3x. Sorry, x squared, 3x squared over 2. 24 must be equal to 3x squared, which means x squared must be equal to 8, which means x must be equal to square root of 8, which is equal to 2 root 2 centimeters. So that's part A done. So part B, find the length of BC. So if I were to draw this out again, then I know this must be 2 lots of x, so it must be 2 lots of 2 root 2, which is 4 root 2. This must be 3 lots of root 2, which is 6 root 2. I know this is 30 degrees, A, B, and C, and I'm trying to find out B to C. So that means I'm trying to use the cosine rule. So using a squared is equal to b squared plus c squared minus 2bc cosine A. That means A is what I'm trying to find, which is bc squared. So bc squared must be equal to 4 root 2 squared plus 6 root 2 squared minus 2 lots of 4 root 2 times 6 root 2 times cosine 30. Which means BC squared will be equal to 16 times 2, which is 32, plus 72 minus 96 times cos 30, which is root 3 over 2. This means if I put this into my calculator, BC squared must be equal to 20.861564, which means BC must be square root of 20.861564, going on forever, which means BC must be equal to 4.56744458, which means BC must be equal to 2 decimal places, 4.57, and it was measured in centimeters, so 4.57 centimeters. A parallelogram ABCD has an area of 55 centimeters squared. So if I draw my parallelogram, like so, let's call this A, B, C, and D. Area is equal to 55, so area is 55. Given that AB has length 5 centimeters, AB is 5, and BC has 12 centimeters, BC has 12, and angle ABC is obtuse. Okay, my sketch is correct because my ABC is obtuse. If it wasn't, I'd change my diagram so it was obtuse. Find the size of angle ABC to 2 decimal places. Okay, so first thing I need to do is, because the parallelogram, I can split it up into two triangles. So the parallelogram becomes two triangles, and then I can use the area of a triangle to find out what angle ABC would be. Okay, so using area is equal to half AB sine C. Then area of this triangle will be half of the parallelogram, so which means 55/2 must be equal to half times 5 times 12 times sine of angle ABC. Okay, so I've got 55/2. So I've got a 2 then over 2 there, so I can cancel that out. So I get 55 must be equal to 12 times 5, which is 60, sine of angle ABC. That means the sine of angle ABC must be equal to 55/60, which is the same thing as 11/12. So angle ABC must be equal to inverse sine of 11/12, which is equal to 66.443535, going on endlessly, which means angle ABC must be equal to 66.44 degrees to 2 decimal places. Part B, find the length of the diagonal AC to 1 decimal place. So for part B, if I draw out this triangle, okay, A, B, C, I'm trying to find this diagonal. I know this is 5, I know this is 12, and from part A, I know this is 66.44 degrees to 2 decimal places. Then I know I need to use cosine rule because I don't know a opposite length and angle. So using A squared is equal to B squared plus C squared minus 2BC cosine A, I get A to C squared. A to C squared must be equal to 5 squared plus 12 squared minus 2 times 5 times 12 times cosine of 66.44 degrees. If I put this into my calculator, I get AC squared is equal to 121.04168848, which means AC is equal to square root of this number, which means AC is equal to 11.0018946, which means AC must be equal to 11.0 centimeters to 1 decimal place. Okay, the next example. Find the area of triangle ABC. Okay, now to find the area of a triangle, I need 2 lengths and an angle in between, which I don't have here. So I need to find out one other length first. Now, because I know this is 24 and 39, angle ABC must be equal to 180 take away 24 take away 39, since angles in a triangle are equal to 180 degrees, which means it must be equal to 117 degrees. So this is 117 degrees. Okay, so now using sine rule, because I've got an opposite length and angle, so using sine rule, I can either find the length of AB or the length of BC. Let's find out the length of BC. So using A over sine A is equal to B over sine B, because we're trying to find a missing length. I've got X over sine 24 must be equal to 40 over sine 117. If I rearrange it, I get X must be equal to 40 over sine 117 times sine 24, which means x must be equal to 18.25964, blah, 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 which means x must be equal to 18.26 centimeters. So this is x is equal to 18.26 centimeters. Now, because I have two lengths, and an angle in between, I can use the area of a triangle rule. So using area is equal to half AB sine C. Area must be equal to half times 40 times, let's use the non-rounded version, 18.25964, just for accuracy levels, sine of 39. If I put that into my calculator, I get 229.8233796. And if I want to round this to 2 decimal places, I get 229.82 centimeters squared as my answer. The only other concept I need to go through are bearings, because they can come up on these questions as well. So bearings are measured from the north line, so always going up, starting from the north line, which is going up. Measured going clockwise from north line again, and they're always written in 3 figures. So if we have a point A and a point B, and let's just say we draw a north line at obviously A, and this angle here is 60 degrees, then the bearing of B from A is represented by, from A drawing a north line, which you already have there, and from the north line you go clockwise to B. What is that angle? It's 60 degrees, but you also need to write it in 3 figures, so it will be 0, 60 degrees. If I were to do it the other way around, which is bearing of A from B, that means I need to draw a north line at B, and then from that line I need to go clockwise all the way until I hit the line that joins up to A. So this is the angle I'm trying to find. Now, because this is 60 degrees, I know this, because it's a C angle, corresponding angle, that means, so supplementary angle, this must be 180 take away 60, which is 120 degrees. Angles around a point must be 360 degrees, so the other part must be 240 degrees. So the bearing of A from B is 240 degrees. Okay, so just remember 3 points. Measured from the north line, going clockwise, and written in 3 figures. Let's go through an example. A boat sails from point A on a bearing of 80 degrees for 16 kilometers to point B. So if I were to draw this out, so we've got A, north line, is traveling on a bearing of 80 degrees. 80 degrees an acute angle, so something like this. So this is 80 degrees, and it gets to a point B. So let's say somewhere here, B, and that's 16 kilometers, so we've got 16 there. The boat then sails 19 kilometers on a bearing of 225 to point C. So again, draw a north line at B. 225 is somewhere here, so somewhere there, which is, whoops, maybe I have made that too long. Okay, so 19 degrees, this is 225 to a point C. So that's the first part. So if I have to draw a diagram out, this is how it looks. Part 1, it says show that angle ABC is 35 degrees. So ABC is this angle. So what is this? This is part 1. You're trying to find out that. Okay, so I know if this is 80 degrees, that must be equal to 100 degrees because of it being a supplementary angle. Okay, so angle ABC, then I know angle ABC must be equal to, because it's around a point, it must be equal to 360. Take away the 100 that I just labelled. Take away the 225 that is labelled on the other side, which gives me a value of 35 degrees. Part 2. Find the distance the boat has to travel to get from C back to A. So for part 2, I'm trying to find out this. So if I redraw it, I've got this triangle where I know this is 16, I know this is 19, I know this is 35 degrees, and I'm trying to find out this. Okay, so that means I need to use the cosine rule. So using a squared is equal to b squared plus c squared minus 2bc cosine a. Let's call this value x. X squared will be equal to 16 squared plus 19 squared minus 2 times 16 times 19 times cosine 35, which means x squared must be equal to 118.95555571, which means x must be the square root of this number, which means x must be equal to 10.90667, which means x must be equal to 10.9 kilometers to 1 decimal place. Part 3 says find the bearing on which the boat must travel to get from C to A. That means I need to draw a north line, and I'm trying to find all this. Okay, so the bearing from C to A. Now I know if this is 135, then that must be 45 degrees. So this little bit here must be 45 degrees. So this here, if I shade it in, this is not very clear to see, that shaded part must be 45 degrees. So what I need to do first is I need to find this, let's call this y. So to find y, I need to obviously use the sine rule. So part 3, using the diagram above and the sine rule, using sine A over A is equal to sine B over B, x is equal to 10.9. Then I get the sine of y over 16 must be equal to sine of 35 over 10.9. So all I've done is apply the sine rule to that triangle here. That means sine of y must be equal to sine of 35 over 10.9 times 16, which gives a value of 0.841947, which means y must be equal to inverse sine of 0.841947, which means y is equal to 57.35 degrees. That's not what we're trying to find out here. So we've just found out the whole thing there. So let me just use a different color. So this y is all of this. So if I want to find the bearing on which boat must travel, because angles around a point are equal to 360, it must be 360 take away the value I just found out, which is minus 57.35. But I need to, because I've taken away the red part which I want in my bearing, I need to add that red part on, which is 45 degrees, which gives me a value of 347.653, which is roughly 347.7 degrees. So that would be my final answer. So just to explain it again, angles around a point is 360. The green part, which is y, is equal to 57.35. If we take off that part, we're taking off the 45 that we do want. So we have to add the 45 back on to get the final answer. So don't forget, in sine, cosine rule and area of a triangle rule, bearings might come up as well. So make sure you brush up on your knowledge on bearings.